digital leader. I work at Jim's Wellington Academy, Khail, and I've got 6 students who came around with me. I wanted them to show you some of the work that we do. Now I know that the theme for this session is, and for all the sessions, is to do art. So I wanted to do how art stimulates your children and what you do to teach, to help with art, to help with your subjects. Now I teach computing, but I think it's important that you teach art in every subject that you do. It's incorporated in the lessons that you do. I'm a primary school teacher trained. I've only started doing secondary school teaching for, this is the second year I've been doing secondary school. But I think that having a basic understanding of primary school and how art is linked to the subjects in there is really valuable in secondary school, all the way down to sixth form, as much as it is down with younger children as well. So I've got a little starter as an example. And I like to do the drawing up here. I like being creative. Last year I was trying to teach children infinity, and infinity is a really difficult concept to understand because it's enormous. The brain can't really fathom how big infinity is, or in fact how small infinity is. And as the class, we looked at Kandinsky, and this is a piece of Kandinsky's art.
Sorry.
That's all right. And Kandinsky used to work a lot with circles, and he talked about how many circles you can fit within a circle. Now we looked at infinity and we drew a circle, and how many circles do you think you can fit in a circle? I'll ask one of the students. Tazeen?
Infinity?
Yeah, you're right, absolutely right. It's like I trained you, but I didn't really know. Right, you can fit infinite circles in here, right? Infinite. If I pick just one of those circles, how many circles can you fit inside that circle? Yeah, absolutely right, infinity again. And then how many within that circle? Infinity. Now as a class, we looked at how many levels of infinity. And actually, if you have infinite circles within here, and then you also have infinite circles within here, and infinite circles, that's 3 levels of infinity. There's no such number as 3 times infinity. And suddenly you start to not understand and understand at the same time. You understand that actually infinity is such an enormous number that you can't calculate it. If you think about the number of numbers there are in the world, and then you think of just the numbers 1 and 2, how many numbers are there between 1 and 2? 1.1, 1.2, then you can go 1.12, 1.1112, and there's infinite amounts of numbers within those infinite amounts of numbers, and those infinite amounts of numbers, and it's a terrifying concept to have. But I think not being able to see the artwork and doing this, you don't understand how big infinity is, or even how small infinity is. I think that art really helped us to understand those levels of infinity in that Year 6 class. I think if we'd have done it a different way, they wouldn't be able to grasp that concept. I think that's something I'd really like everyone in here to take away today, is that you can use art to stimulate any subject with your children, whether it's digital learning, whether it's maths, English, geography. Art is such an important concept for children to be able to grasp so easily that it can link to such complicated and difficult things they have to learn. There are so many reasons to use art during your lessons. I don't want to just touch on a few, but for me, being creative is so important. I really don't like being stuck in one place doing one thing. I think everyone feels that way. I think it's such an insulting thing to say, I don't think you're very creative. No one says that to anybody because it really hurts your feelings. Everyone is creative, they're just not given the opportunity to be. And if you use art in your lessons, you get the opportunity to be creative. All the pieces of work are different. I hate getting all work that's all the same. It is really dull for me to mark, and I don't tend to mark all work that's all the same. It's boring, it's tick, 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 done. But it's really nice when all the work is different, and you say, well, that's great because you use this and use this and use this, and people can be so self-expressive, and it's open-ended, so that work is all completely different, but all achieving the same task. It's multi-sensory, it uses different parts of the brain, so you get excited for different parts doing different things, and it's your own creation. It really gives children some real self-esteem when they get to be able to create some artwork in a lesson, regardless of what the subject is, because they own it, it's theirs, more than just something of a task you've given them. More than anything, I think this is the most important one, it feels like a process. It's not how it ends up, It's me continuously making it better, continuously making better, continuously making better. We can improve this way, this way, this way, and they feel intrinsically they can do that. Not me telling them. If they want their art to be better, they can do that.
Sorry, sir.
No, that's all right, come in. Art is an analytical thinking concept. You have to have logic. There's some planning and pre-thinking there you have to do for it to be any good. You have to take a second and go, right, what am I going to do? How am I going to go through this? What makes it good? Oh, I don't like that. When you own that, you start to make that analytical thinking yourself. It's great for displays. Have a look at the children's work. You're going to go, I'm not going to do much talking today. I'm not big on talking. I like the children showing off their work. So please go to see the children. And it's great for displays. You can print it off and that works on the wall. So it really shows off how good your work is. I think maybe the best one is it's also fun. Children really like doing it. We've done a few projects and the children do too much work. I've done 4, I've done 5 pieces. I'm only supposed to do 1, but I really want to do a few more. And it's good like that. Sometimes we make it competitive. We don't really compete against each other, you compete against yourself. I don't want me to stand up here and just talk about it. The children have got computers, and I'd like you to go to them and make your own work. I also think that you guys standing here listening to me boring drone on about it won't actually get you to do anything and take this away to your practice. What I'd really like to do is go see the children and go create some pieces yourself. Get involved in the process, see what that process was like, see what it feels if you like to create, discover and learn, and then hopefully you can take that concept away with you. This is what we did with the Year 9s this year at the start of the lesson. We worked on binary. I'm going to assume that everybody knows nothing about binary, which is fine. But binary is a concept that all computers work on, which is zeros and ones. You might have seen the matrix where you see zeros and ones flying around. That's how the language computer works. And it's how a screen works. And we made our own avatars, computer characters, using just zeros and ones, just like a computer screen works. Computer screen here, this brown little person here is told to be brown with zeros and ones. It's exactly the same on a computer. I'll show you some of the class examples. This is ESAM. ESAM, give us away, please. Give us away. There you go. This is ESAM's. And ESAM created a, not Angry Bird, Flappy Bird, isn't it? Flappy Bird. And it works in the simple concept of you type in a number, and that colour comes up. ESAM don't worry, I'll delete these so that they won't be up there. Alright. Now, if you type in a 2, it doesn't work, because it only works with 1s and 0s.
Excuse me, sir.
So, it's a really nice concept, but all the children created their own. Look at all, these are all the ones the children have created. Some of them went too far and created ones that were too big, but it's really lovely, and they were able to create their own and personalise their own, and everyone was different, and they spent too long on it. But it's a really, really nice concept and fun thing for them to do. What I'd like to, it also, for me, it taught them binary. They understand how it works. They understand the coding of a computer, that there is a signal sent to that screen that is turned on or off, just with 1s and 0s. And that's the only way a computer can work. It can only work with 1s and 0s, on and off. And this is a very difficult concept for anybody to understand. But using art makes it very, very simple for them to go, right, I understand this little purple here is a combination of 1s and 0s, so that actually I can understand how that screen is created and how the computer works. If I gave them a book and we wrote questions on it, I think they would not learn it, not nearly as well. So here's what I'd like to do. I've got 4 children. Ariana, give us a wave. Nadia, Isam and Tazim. And please go over there, and I'd like you to create these yourself. And understand what the process is, because hands up who understands binary. Does anyone understand binary before they came in? That's really good, because I don't want you to understand anything. I'd like to go to the children and go ask them questions and create using that so you understand. So we've got about 15 minutes. Please go over to the children and go and create. So if I limit the colours,
You're not coloring.
these will also limit the colours.
For example,
If I make more colours,
a tree.
I can make it, yes, make that computer more powerful to send
You have to
more bits.
create
How was it doing, teacher?
Yeah, I was doing that.
I don't mind if you keep talking to the students, but I'll keep talking as well so we can move on to the presentation. When I introduced this was an art competition, and I think we did this for 1 week, right? And I asked them just to do one piece, but they all did 3 or 4 or 5, okay? Because they were motivated by it, they enjoyed doing it. It was all personalised, they're all different. One of the nice things, they could all see each other's as well, and they could see each other's art pieces, so actually they were motivated and they learned from each other. We did say who could design the best, and it was a little mini competition, but really, I think they're all pretty proud of their work internally, rather than how much they did. The point of this is the learning, really, and as much as it's fun and enjoyable, it was what they learned when they were doing it, and they understood how binary worked in the real world. Now, when you talk about binary, it's quite a dull subject. It's not the funnest thing to be able to teach. Well, not in other people's opinions rather than mine. But the point of this is it teaches them the real practical application of this subject. When we looked at, if I look at this one here, and this is, I think, Ethan, this one's yours, right? And this is where we did, he did a basketball player. This is the NBA simple logo, right? And the children went online, looked at some examples of logos, and then, I suppose you're going to call this pixelated it, but really they've made it into binary. And it's a very, very simple concept, in that you have one bit of information per pixel. And it helps understand that if you send zeros or ones, that's only 2 colours. And when we had basic computers and basic TV screens, it would just be in black and white. So you only send one bit of information per pixel. If you want to make a more quality colour, a more quality, you'd have 2 bits per pixel. So you can send 2 bits of information, 1, 0, 10 and 11. Ons and offs, just a variety and a combination of those. The same with 8 bits, 3 bits per pixel, 8 colours, 4 bits, which is 16 colours, 5 bits, which is 32, good. 32, you're right, 32, and it goes up in those powers of 2. Alright, but it teaches that practical way of learning. If I'd have done this in a dull way, where we just looked at the powers of 2 and just going up in that way, it would have been quite dull and not as interesting. I think it links back to talk about the levels of infinity. It's a practical application, but using artwork to do it. This isn't any Kandinsky work, but it is nice. It's all personalised and created, and the children feel like they owned it. It was a really lovely activity. We only did for 2 weeks. Here's what I'd like to show. This is our second activity that we've done this year with art. And programming is a very difficult thing to understand. Just a show of hands, does anybody understand JavaScript? Oh, there you go. That's right, if you understand it a little bit, that's okay. But the basic premise of JavaScript is a language that creates artwork on a computer. So when you look at any avatars, they're created through JavaScript. Or you look at pictures, they're mostly created through JavaScript. And we made, it's a very difficult thing and difficult concept to understand, but if you apply it to art in a creative way, then actually children can learn it and pick it up very, very quickly. It works on this premise. I'll show you some examples of the children's what we've done. This is JavaScript, and it looks, or maybe if you've not seen it before, it looks ludicrously complicated. And the year 9s, you haven't seen that before, so you maybe don't understand it either. But it's a very, very simple concept to pick up once you start applying it to something practical, like a piece of art. You might see some rectangles, awesome. In this one, I suppose, you have ellipses. Make sure I spell it right. Teachers can't really spell right usually. And in each ellipse, you have 4 values. You have an x value, so the plate is 200. by 200. And those are the x and y values. So if I move the plate, lost my mouse now. So this will move the plate left to right. So this is the y value, so that one will move it up and down, correct. Then you have two values there, which are w and h, and they are width and height. 350 being the width and 350 being the height. So I want my circle to be a perfect circle, because it's the same wide as its height. And then I've filled it a certain colour. So this is purple, but I can also turn it a different colour there. Now, this was set over 2 weeks, and the children learned how to make their own piece of art. Now, if we'd have done it as a question, what does X do, what does Y do, it would have been quite a dull subject for them to do. But as a concept of art, it meant they could create their own art piece. These pieces went on the walls, and we created some beautiful artwork pieces, really, really nice. I'm conscious there are a lot of people in here now, and actually people being able to go to Quentin and Ife might be a bit limited. But what I'd like to do is, for the next 5 minutes, if you can go over to Quentin and Ife and they'll show you some examples of theirs. If not, do pop over to the other two over there and we'll see some art examples. If not, what I'll do is I'll show you some examples on the board for the next 5 minutes so you can see practical examples of what we've done. So Quentin, give us a quick wave for me. Quentin's over there. Please go and see him and go see his artwork. And where's Ife? Give us a wave. Ife's over there too. Please go and see him. Go ask him some questions. How did you do this? What does it look like? And actually how it taught them to be able to practically apply their knowledge of computing through art. If not, and if they're a bit busy, please go see Fazine, give us a wave, Isam, Nadia, and Ariana, and go ask them some questions about their work. And all we'll do is in 5-7 minutes we'll come together and just talk about it as an end. But I don't want to talk here forever, I'd like you to talk to the children, that'd be great. So please go and talk to the children so you can get an opportunity to see what their work is.
Because if I don't want to see the program, I just want to see the output.
Some people ask that. So if I show you, it's not actually my idea. I mean, this is quite a common thing that computing teachers do here. So if I show you a video of how to do it to your own Excel spreadsheet, and all you have to do is put that. Right,
you mean by
I think the children have done a really excellent job. It's really nice of them to do all my work for me. I think that it's really good for you to talk to children and see what they think and how they think of the artwork rather than me telling you, because I can tell you as much as I want, but it doesn't really benefit education if I'm a really good understander of what I'm doing. Really, if the children, I think they've done a really, really good job, so please say thank you to them as you go out. I'm hoping that people went away and go, actually I learned something, not about education or taking art, but actually I learned something about computing today. I learned how to do something. And I hope you learned how to do something because it was linked to art. It was linked to something creative. It was linked to something that I could relate to, rather than a textbook, rather than a test. Those things are important, but it's great to have some kind of art to stimulate. I want you to think about how you can apply this to your subject. I know I'm a computer teacher, but the purpose of this is that you can take art back to your own subject, whether it's English, whether it's geography, history, whatever it is, just so you have a creative side that's applicable to your own subject. And why did you learn? I'm hoping I'll bring up some of those things afterwards. I want to look back to this, and hopefully these are some of the things you can relate to for today. I felt creative. I know the children definitely feel this. You feel like a creative thing that actually I can create this myself, and I'm learning because it's fun and enjoyable. But also it's personalised. I hope you saw the children's work was different. They got to put their own spin on it, their own ideas. They had their country's flag, or they had their favourite sport, or things they like, because it's from inside, their work from where they are. It's multi-sensory. They know the children get different ideas from different places, and it brings together their brain in a different way than just reading. It's a process. The children don't learn at the end. It's not right, I'm done, this is a perfect thing. It's the process, it's the learning of the coordinates, or the learning of the binary language, or the learning of how many bits per pixel, and how I can make that image better, and how I can how I can do that. It's the process of doing it. That analytical thinking, logic, planning, having a think about it before you actually do it, and applying those skills to real life. It's great, and it's easy work to display. You just print it out and put it on the walls, and it looks beautiful. And sometimes that's difficult with some of our subjects. But it's a really nice way to be able to promote what you do on your subject. And finally, I like to think it's quite fun. I think that when you see the children and see how motivated they are, it's enjoyable. And actually, hopefully, you bring some kind of fun to your subject that they buy into. A few people have asked me if they would, how you create the Excel spreadsheet. And I have a video link, so you can create it yourself if you want to. It's very simple. Create an Excel spreadsheet with some conditional formatting, and you spread the link out. The same with Khan Academy. Khan Academy is great. As long as the children are old enough, you can create their own account. And it's a great way of teaching children through videos, through the creative process, and it's a really, really applicable way for them to learn. And that's it. I think there are some feedback sheets that Steve would like you to fill out, if that's all right. But if you've got any questions or anything else, that'd be great. If you want the link to the video, do come and see me, and I'll put it on the screen for you. But one thing, just say thank you to the children, because they did a really fantastic job. So thank you to everybody. All right.